Lesson 3.2, this is the do the math. So we're looking at analyzed graphs of polynomial functions. So let's get started. It says find the following for the graph of f of x in behavior, zeros, max and min, and the sign of the function for intervals between your zeros. All right, so in the last part, I showed you that you can just graph this, and if you graph this, it's very easy to find these things. So let's use our graphing calculator to simply sketch the graph of f of x. All right, so we can say x plus 3, and it's in factored form, so you can leave it in factored form, and your calculator will graph it. Even though this is a cubic function, sometimes factored form is easier to see some of the solutions. All right, so you can see I have entered the factors here. So x plus 3, x minus 1, and x plus 1. We know that x times x is x cubed. So even though we don't know the exact standard form, we do know that this is a cubic function. So you should know the general shape of a cubic function, and this is it. So now we can determine some things from the function. So it says first, what is the end behavior of the function? Select the words from the drop-down box to list the complete. All right, so as x approaches negative infinity. All right, so x approaches negative infinity when it goes to the left, because this is the negative x's, this is the positive x's. So if we're looking at the negative x's, we're going towards negative infinity, and your y's are also going negative. As we go to the right, x's go positive, y's go positive. So let's fill that in. So x approaches negative infinity, f of x, or our y, also goes to negative infinity. As x approaches positive, f of x also approaches positive, because again, you could see that it's going up in that direction there. All right, so that's our end behavior. And then it says, what are the zeros of the function? So again, if you have the graph here, it's easy to see that the zeros are here, here, and here. So your zeros are where it crosses the x-axis. You can go second trace and ask your calculator to find the zeros, but at the same time, sometimes it's easy to just visually see that. So if I just look, I don't need to do my zeros right now because I think it's easy to see that that's negative 1, 2, 3. So negative 3, negative 1, and positive 1. So I'm going to have negative 1, negative 3, and positive 1 would be my 3 zeros. Also need to look that if this is a cubic function, 1, 2, 3, it's going to have either 3 zeros or 1 0. So it makes sense that we have 3 zeros here. So what I mean by 3 or 1, if this hump here was below the x-axis, then it would only have one place where it crossed the x. So it would only have 1 0. But if this goes above x and back below, then that's what creates 3. Cubic function has 3 zeros, but if this hump falls below that line, it would have 2 imaginary zeros, which we learned about imaginary numbers in the last unit. It would still have 1 real solution. But in this case, it crosses 3 times, so it does have 3 solutions. Most cubic functions will have 3. Some will have 1 solution. All right, what are the max and the min of the functions? Okay, again, we can tell that by looking. This is the maximum, the local maximum, and this would be the local minimum. So you can, you probably can just hit trace and get the little cursor and get a general idea of what this is. So if you just kind of get up there close to that, you're going to see that negative 2.1 and y equals 3 is your maximum. So it says, these both say minimum, these say maximum. So we know that negative 2 something is going to be our maximum. And let's see what the minimum is going to be. So if I just scroll over to that lowest point, it's going to give me a minimum of about 0.2 and negative 3. So this one says maximum. Again, this is our minimum value. So the minimum comes at this point. The maximum was at the other point. So it had a maximum of this and a minimum of this. All right, then it says, what is the sign of the function for intervals between the zeros? Drag the inequality into the box to correctly complete the sentence. The function is negative on the intervals blank and blank, and the function is positive on these functions. All right, so it's negative when it's below the x. All right, so when it's below the x, it's negative. So it's going to be negative here, and it's going to be negative here. Okay, and then it's positive. It's above the x on this interval and on this interval. So this is about negative 1, 2, 3. So everything less than negative 3. And then our next interval would be from negative 1 to positive 1. So from negative 1 to positive 1 is also negative because it's below the x. And then the positive intervals, we can see it's positive from negative 3 to negative 1. Make sure I get the negative 1 there, negative 3 to negative 1. And it's also positive on everything greater than 1. So everything greater than 1 is also positive. All right, going to question 2. This one says an open box is formed from an 8-inch by 10-inch rectangular piece of cardboard by cutting an x by x square from each corner and folding the sides up to create a rectangular box. What value of x to the nearest tenth maximizes the box's volume? All right, so if we look at this, and I can't draw, so please, let's see if I can get a rectangle here, at least to get started. Oh, that'll help a lot. Okay, so we have a rectangular box, and we're going to say that we cut an x by x square out of each corner. All right. My drawing is far from perfect, so don't judge me on my artwork here, but we just need something to represent what we're talking about. So we know the corners are going to be cut out, and we know they have a distance of x. We also know that it's 8 by 10 inches, so 10 would be your longer side. Sorry about this. I need a new computer, but haven't got one yet. Let's see. So 10, and this one is 8. So 8 by 10. All right, so first thing we need to do is it's talking about what is the value of x to the nearest tenth. That'll be important when we do our answer. The maximum of the box's volume. So we know that volume of a rectangular figure is length times width times height. And we can use the image that we have here to say, all right, our length equals what? Our width equals what? And our height equals what? All right, height is the easiest because when we take these corners and we fold this up, because this is one flat sheet, a piece of paper, but the reason we're cutting out these corners is because we're going to fold this up to make a box, okay? So the height will be as tall as that length right there, which is just x. All right, the width is the shorter of the two sides. So you got length is the longer side, width is this side, and this is going to be 8 minus 2x. And your length, 10 minus 2x. And again, we're subtracting those x's off the corners because those are not going to be part of the length. Once they fold up, those are going to be on the sides of the box. So in order to find the answer here, you're going to just substitute this in. So we're going to have 10 minus 2x, 8 minus 2x times x. And we can do this very quickly, hopefully very quickly, using our calculator. So let's go back to our graphing calculator here. Don't know where a good spot to put it is where we can see it, but let's try over here. So clear out the last one. And then we're going to enter the new one. So we're going to enter 10 minus 2x, 10 minus 2x, 8 minus 2x, and then times x. We're going to hit graph. Alright, now what we can see here is that it goes up, but you can't see the maximum here, and then it comes back down to the minimum. So let's change this maximum. It looks like it's going to go way higher. So let's go to window, and let's change. We don't need the x's changed. We need the maximum y value changed, because when you're looking at the top, when you're looking at what's the height here, that's your positive y's. So we're going to come down here to y's, and let's just jump up to about 50. Let's see what happens. All right, we can almost see the top now. We still can't see the top, but we can almost see the top. So let's go a little bit higher. And now we can see the higher. So if we just hit trace, and again, we're going to try to find that maximum number there. So this is about 1.49. So it's going to be about 1.5. So our x is about 1.5 when the y value is the volume of the box. So when the volume of the box is 52.5 inches cubed, then that means our x, the length of x, is about 1.5. And the reason I'm saying 1.5, if you remember, it says round to the nearest tenth. So x should be about 1.5. And that's how you would find the length of x. If you have any questions, please let me know.